Well, I thought my first print was going to turn out neat and clean, just like the videos I would watch. But I wasn't really paying attention to the settings. I just hit print and well, you can see for yourself. I rushed it a bit and that's exactly how it turned out. Hi, I'm Amir and this is the Amir Makes channel. In this video series, we are going to learn the Slicer software together through building different objects. When you download or design a 3D model, it's just a digital surface. Your printer can't understand it directly. The slicer cuts that model into thin horizontal layers, and for every layer it decides exactly where the nozzle moves, how fast, and how much plastic to push out. The final output is a G-code file that the printer reads directly. Every settings you will learn in this course, from layer height to speed, is changing exactly those instructions. Before we install anything, it's worth knowing the slicer is not the only option out there. Bambu Studio is built for Bambu Lab printers, focused on speed and automation. OrcaSlicer is a free, open source option that supports a huge range of brands and printers and is popular with advanced users. And Creality Print is Creality's own free, tuned specifically for Creality printers, and exactly what we will use in this course because it's free and easy to start with. The concept you will learn, layers, walls, supports, are the same across all three. Only the button and names or the overall appearance may change. You don't need a specific printer for this course, but it's worth knowing where Creality's lineup stands right now. The Ender series is the base, budget-friendly starting point. The K1 and K1 Max are faster, enclosed machines for tougher materials. And the K2 Plus is the top tier which supports CFS, which is exactly what we are talking about next. CFS stands for Creality Filament System, an external unit that holds up to 4 filament spools and lets you switch colors or even switch materials mid-print without manually swapping spools yourself. In Creality Print, once it's connected, it's detected automatically, and you will see each spool listed separately in the settings panel. You don't need one for this course, but since you are working in Creality Print, it's good to know the capabilities there. Let's get it installed. From Creality's official site, download Creality Print for your operating system. Windows, Mac, and Linux are all supported. Run the installer with default settings, and once it opens, the first thing we will do is select your printer model. After installation, the software asks you to select the mode and then your location. Here you can log into your Creality account, or you can skip it for now. And then there is 2 modes to connect it. You can connect it manually, or you can connect it using a LAN cable. We can opt out of connecting our printer by cable. Find your printer in the list. If it's not there, add it manually. Confirm your nozzle diameter. Before your very first print, level the bed. Most newer printers have auto leveling, but even those are worth a manual check the first time. This step is the foundation for every print that follows. This software gives you a brief tour about all the buttons and the interfaces, so you can find your printer on top left corner of the software. Also, you can connect it to the Wi-Fi and use the IP address of your printer. This is the button that you can import your STL file or your digital model. This is where the filaments reside, and you can select between different filaments that you have in your system. And these are the two main buttons. One is a slice the plate, which slice your 3D files, and the next one is the button to send the sliced file to your printer and start the print process. This center area is the build plate. It maps directly to your printer's bed, and your models go here. By going to the device tab on the top of the software, you can add your devices to the panel, and also you can share the stats of your devices with the software. That's how you can see the printer temperatures, the printer cameras, what you have, what state your printer is at, and what is the percentage of your printing model. So these are very good information. You can click on the detail button. You can see the CFS stat. You can see I currently have one CFS, and it shows all the spools and colors on the CFS. And if I go on the details, I can see the camera, that there is a benchy on the build plate. I can see all the spools and their stats, if they are full, half, or they're near empty. Also, I can see all the temperatures. I can see if there is anything on my extra spool holder, and also at the bottom left I can see the printing stat of the model on my machine. So this is very helpful when you connect your printer to the Wi-Fi and then connect it to your software. Let's go and import a simple model and hit a slice. So we can do that by right click on the build plate, and then this menu opens up, and then you can click on add testing primitive, and then we go there and we can import this classic 3D benchy. And now we have the benchy and the build plate, and then we can click on the slice button, and we will the preview tab opens up, and we can move the layer slider. So this is the layer slider. We can see the nozzle movement on each layer, and you can see exactly how the model gets built from bottom up. So from layer 1 to the top layer, which is layer 240, we can see that. And this is exactly what we will use in episode 1 to make our first real print. Also, we can see that this, the slicer has a simulator option at the bottom, so we can click on play, and we can see the nozzle movement while the printer prints this part. So we can see that the nozzle is making an outer wall using this color codes or color map. At the left side of the screen, we can see what exactly the printer is doing, and it shows all the steps. We can move the slider back and forth, and it shows the movement at layer 1. Then we can go up at different layers and then simulate the nozzle movement at each layer. Then it goes layer by layer. It goes to the next one, the next one. That's how we can find out if there is any conflict, if there is any collision between parts or a nozzle hits anything that it should not hit. If you are here for practical, no jargon 3D printing, subscribe and let's keep going.